Hi, in this video, we are going to see about equalization and its types. Introduction. Equalization technique in wireless communication is a technique that combats distortions caused by the channel, particularly inter-symbol interference, and to improve signal quality. It works by reversing the effects of the channel on the transmitter signal, essentially making the frequency response flat. Equalization techniques can be broadly classified into linear equalization and nonlinear equalization with digital and analog implementations. The types of equalizer. These are simpler to implement and suitable for channel with relatively flat frequency response. First type is transversal equalizer. These use a tapped delay line to filter the received signal. Zero forcing equalizer. These aims to eliminate inter-symbol interference by setting the coefficients of the equalizer to zero. Least mean square equalizer. These adapt the equalizer's coefficients based on the received signal and a training sequence according to ANSYS innovation space. Nonlinear equalizers. These are more complex and can handle channels with severe distortions. Decision feedback equalizer is a type of nonlinear equalizer, and these decision feedback equalizers use the detected symbols to estimate the inter-symbol interference and remove it from the received signal. Maximum likelihood sequence estimation. This technique tests all possible data sequence and choose the one with the highest probability. Linear transversal equalizer. It is also known as tapped delay line equalizer, and it is a simple type of equalizer used in digital communication systems to combat inter-symbol interference. It works by using a tapped delay line to store past received signal samples, which are then literally weighted by adjustable coefficients and summed to produce the output. Working of linear transversal equalizer, tapped delay line. The core of an linear transversal equalizer is a tapped delay line where the received signal is delayed by successive symbol periods and taps are placed at each delay stage. Linear weighting. Each tapped delay line output is multiplied by a corresponding adjustable coefficients. Summation. The weighted outputs from all the taps are then summed to produce the equalizer output. Adaptation. The tap weights are adjusted to minimize the residual ISI, often using algorithms like the least mean square algorithm. Next, this block diagram shows the structure of linear transversal equalizer. The current and past values of the received signal are linearly weighted by the filter coefficient and summed to produce the output. The minimum mean square error of the linear transversal equalizer is given in this equation. Activity. Nonlinear equalizer. It is a technique used in communication systems to compensate for channel distortions, especially when linear equalization methods are insufficient. It's particularly useful for channel with deep spectral nulls or severe non-linearities that linear equalizer struggle to handle by employing feedback and nonlinear functions to improve the performance. Already we've seen the three types of nonlinear equalization in the previous slides. Decision feedback equalizer. It is a type of nonlinear equalizer used in communication systems to mitigate inter-symbol interference, which occurs when the signal from a previous symbol interferes with the current symbol's reception. It works by making decisions about the received symbol and using this information to adjust the equalization process, effectively cancelling out the interference. And how the DFE works. The core principle of a Differential feedback equalization is to estimate and subtract the interference caused by previous symbol. The feedback filter that uses previously detected symbols to predict and cancel out the interference. A feed-forward filter similar to a standard linear equalizer is used to further refine the equalization process. It can be implemented with fixed or adaptive taps that are adjusted based on the channel conditions and received data. It relies on making decisions about the received symbol to guide the feedback process, and its output is given in this slide, and the minimum mean square error is also given in this equation. This is the block diagram of the DFE. Nonlinear equalizer, particularly using maximum likelihood sequence estimation, and it is a technique employed to mitigate distortions in communication channels, especially those with severe amplitude distortion or deep spectral nulls where linear equalization struggles. MLSE, as a form of nonlinear equalization, focus on finding the most possible sequence of transmitted symbols given the received signal, thus addressing distortions that linear method cannot fully resolve. The block diagram of MLSE is given in this slide. While MLSE offers significant performance gains, it can be computationally complex, especially for higher order modulation scheme or channel with long memory. The number of states is grows exponentially, increasing the computational load. Advantages: it can be particularly effective in channels with strong nonlinearities as it accounts for the channel's nonlinear behavior in its decision-making process. This makes it a robust technique for compensating of various forms of distortion. It requires knowledge of the channel characteristics in order to compute matrix for making decisions. Assessment. Thank you.